Welcome to my presentation on constructors and destructors in VB.NET. In this presentation, we will explore how constructors are used to initialize objects when they are created, how destructors help in cleaning up resources when objects are no longer needed. By end of this presentation, you will have a clear idea of how to implement and use both effectively in your VB.NET programs. In the slide, we can see what is a constructor. It is a special method that is implemented when an object of a particular class is created. It is also useful for creating and setting default values for a new object of a data member. When we create a class without defining a constructor, the compiler will automatically create a default constructor. We can create more than one constructor in a class with the use of new keyword, but with the different parameters, and it does not return anything. In VB.NET, a constructor is a special method that runs automatically whenever we create an object of a class. If we define a constructor without any parameter, it is called as default constructor. Here, in the example, we have a class called myClass. Inside it, we are using the keyword new to define the constructor. This means whenever I create an object of my class, the code inside the constructor will execute automatically without me having to call it separately. We usually use the default constructor to initialize values or display a message when the object is first created. Now we can see what is parameterized constructor. This is another type of constructor. In VB.NET, when we pass one or more arguments to a constructor, the constructor is known as parameterized constructor, and the object of the class should be initialized with the arguments when it is created. Now we can see example for parameterized constructor. First, we import the system namespace, so we can use console input and output functions like console.writeLine. Then we create a module called paraConstant. This acts as a container for our class and the main method. Next comes in class tutor. Inside the module, we define a class named tutor with the two string variables name and topic. Next, this is a parameterized constructor. Unlike the default constructor, this one accepts arguments. When object of the class is created, we must pass values to it. Here the constructor takes two parameters A and B and assigns them to name and topic. It also prints a message. We are using a parameterized constructor to pass the parameter to show that this constructor is being used. Next, a main function. In the main method, we create an object of the class using the statement dim tutor as the class name, which is equal to new the class name passing two arguments java point and VB.NET constructor. This automatically calls the parameterized constructor and passes the values java point and VB.NET constructor. Next, we print out the values of tutor.name and tutor.topic. These values come directly from the arguments we passed into the constructor. Finally, the read key is used so that the console waits for a key press, giving us time to see the output. Next comes Destructor. Is a special function that is used to destroy a class object when the object of the class goes out of scope. It can be represented as a finalized method and does not accept any parameter nor return any value Furthermore, it can be called automatically when a class object is not needed. Now we can see the syntax of Destructor. Here we have a class named myDestructor. Inside this class, we define a destructor. Next, in VB.NET, a destructor is represented by finalize method. It is declared using protected overrides sub-finalize. So the keyword protected means it cannot be called directly from outside the class. And the keyword overrides means it is overriding the finalized method from the base object class. A destructor is automatically called by the garbage collector when the object is no longer needed or goes out of scope. We don't pass any parameters to a destructor and it does not return any value. Inside this method, we can write a cleanup code like closing files, releasing memory, or freeing system resources. So, whenever object of this class is destroyed, the code inside finalize will run automatically before the subject is completely removed from memory. Now we can see example for Destructor program. We define a class name getDestroy. This class has a constructor and a destructor. Public sub new. This is the constructor. It runs automatically when we create an object of the class. Here it simply prints the message, an object of the class is being created. Next, protected override sub finalize. It is a destructor. This is the destructor. Defined using finalize method, it runs automatically when the object is destroyed by the garbage collector. Inside it, we print a statement, an object of the class is being destroyed. Next, a main function. In the main method, we call another method getDetails. After that, we explicitly call gc.collect. This forces the garbage collector to run and destroy objects that are no longer in use. Finally, the program waits for a key press. Next, getDetails method. This method creates a new object of getDestroy. As soon as we create it, the constructor runs and prints its message. Once this method finishes, the object dest goes out of scope and the garbage collector is free to destroy it. When the object is destroyed, the destructor runs and prints its message. We have learned how constructors are used to initialize objects when they are created and how destructors help in cleaning up resources when objects are destroyed. I hope this presentation gave you a clear idea of how to implement and use them in real programs. Thank you for your time and attention. Thank you.